This is the final section before the midterm. So this is something new. I want you guys to pay attention. But it's not completely new because we're going to be reviewing something that we already know, which is arithmetic sequences. Do we remember arithmetic sequences? No? Let's take a look at our notes. It says class opener right here, but it's really just a review of the notes of arithmetic sequences. So everybody please pay attention here. Earlier this year, the school year, we learned about arithmetic sequences. An arithmetic sequence is a list of numbers, either growing or decreasing, that have a common difference. All right? And I should have put common difference D because we always refer to the common difference as the D value. The common difference must exist between each of the terms. And let's also remember that a sub 1 is the notation for your first number. A sub 2 is a notation for your second number. A sub 3 is a notation for your third number. Okay, guys, you guys need to understand this. Look, if a sub 1 is your first term, a sub 2, a sub 3, a sub 4, right? If I tell you what's a sub 3, you're supposed to say negative 3. If I say what's a sub 2, you're supposed to say 1. Right? It's just notation. A sub 1 is your first one, a sub 2 is your second one, a sub 3, a sub 4. And you should remember this from a long time ago when we did arithmetic. Do you remember this? No? No? Okay, if you don't remember, pay attention right now because you need to know this. Okay? So, what's a sub 4? It's negative 7. What's a sub 2? It's 1. You guys understand that? It's just the order. When I say, what's a sub 5? Well, we don't have an a sub 5 up here, but if you look at the pattern, you'll be able to say what the a sub 5 is. What is a sub 5? Check it out. From 5, it went down to 1. From 1, it went down to negative 3. From negative 3, it went down to negative 7. From negative 7, what would it go down to? Negative 10? Okay, how about this? We'll figure this out in a little while, but at least we understand a sub 1 is the first one, a sub 2 is the second one. Let's talk about that common difference. Okay, it says right here, the common difference is calculated by taking any term and subtracting the previous one from it. It doesn't have to be the first two terms. You pick any number and subtract the one before it. So check this out. D, the common difference D, I put a sub 2. What does that mean, a sub 2? It's the second number 1 minus a sub 1. What's a sub 1? The 5. So I'm going to take the first one and subtract the 5 from it. Not the first one. I'm going to take the number 1 and subtract the 5 from it. Taking my second term and subtracting the previous one from it. So that would become the problem 1 minus 5, which will give me negative 4. So my common difference is negative 4. And that makes total sense because 5 take away 4 is 1. 1 take away 4 is negative 3. Negative 3 take away 4 is negative 7. Negative 7 take away 4 will give us the fifth term. What's the fifth term? Negative 11. So it's safe to say right now that a sub 5 will be negative 11. You guys understand that, right? Yeah. Okay. I hope that it's starting to come back to you. Now check this out. This is also very important. The above list, I'm talking about the list 5, 1, negative 3, negative 7, negative 11 that keeps going on forever. That list right there came from a certain function. It came from a certain machine. Yes, it's a list of outputs of a certain function machine. To find the a sub nth rule, which is the machine that produces the list, we use this formula. Do you guys remember this formula? We had to have this memorized in semester 1.
I don't remember that at all.
Okay, so if you don't remember, that's okay. A sub n, that's just the name of a formula. This is the actual machine that produces the list. What is a sub 1? We already said that's your first number. Plus parenthesis n minus 1, you're going to leave it n minus 1, and the common difference is negative 4. That would be right there, the negative 4. Does that make sense? So it says right here, if we plug in the values of a sub 1 right here, which is 5, plug in negative 4 right there, we'll end up with this equation. A sub n is this equation. Now, it's ugly looking, so we need to simplify it. So what we're going to do, it's already simplified for you, but what I did was I took the negative 4 and multiplied it by n. That's how I got the negative 4n. Negative 4 times negative 1. That's how I got a positive 4. And then after that, I needed to combine like terms, so I combined the numbers with the numbers. 5 plus 4 is 9. and the negative 4 just came straight down. So ladies and gentlemen, this is the machine that produces the above list. And that's what I explained down here, that the function negative 4n plus 9 produces this list. If you don't believe me, check it out. If I were to plug in a 1, Valeria, if I were to plug in a 1, I'm going to get out negative 4 plus 9, which is my first term, 5. Right? If I were to plug in a 2, what's negative 4 times 2? That's negative 8. Negative 8 plus 1, that gives me the second term, 1. If I wanted to find the third term, just plug in a 3, it'll give you this one. Plug in a 4, it'll give you this one. So this machine actually produces this list, and this machine will help you find any number you want on the list. For example, I could find the 20th number on the above list, and the notation for finding the 20th number is a sub 20. That's just a notation. And how do I find the 20th number? By simply plugging in 20. So it says a sub 20 equals, I plug in 20 right into the n. That'll be negative 4 times 20 plus 9. That'll give me negative 80. Negative 80 plus 9 is negative 71. So this list of 5 decreases by 4, 1 decreases by 4, negative 3 decreases by 4, negative 7 decreases by 4, negative 11, decreases by 4, negative 15. Now, again, this is your first number, a sub 1, a sub 2, a sub 3, 4, 5, 6. If I go all the way to the 20th number, that 20th number will be negative 71.
That far?
Yeah. And that's why it's important. You're saying that far. That's why it's important to know the a sub nth rule. Because if you know the a sub nth rule, you could find any number. Imagine this. I could tell you, find the 100th number on this list. Imagine 1, 2, 3, 4, 5, 6, 7, 8, 9, 20, 21, 22, 23, all the way to 100. I already know that that answer is going to be negative 391. Because if I plug in 100 right here, that'll be negative 400. Negative 400 plus 9 is negative 391. So the 100th number on this long list will be negative 391.
What about 1 million?
Okay, so this is a review, but do you see how amazing it is to know this rule, a sub nth rule? Okay. What we're going to be doing right now, this is the real part of the lesson today. Note 7.5, geometric sequences. Okay. An arithmetic sequence had a common difference. On the list that we just did, we were subtracting 4, subtracting 4, subtracting 4. Right? Over here, this list. 5 take away 4 is 1. 1 take away 4 is negative 3. Negative 3 take away 4 is negative 7. Negative 7 take away 4 is negative 11. And so on and so on. Right here, we found the common difference because we simply took a number, and it could be 1 take away 5, which gives us negative 4. Or you could do any number you want. You could do negative 7 take away the previous. Negative 7 take away the previous, negative 3. That'll also be negative 4, as you could see. So there's a common difference between all of its terms. Now, that's what makes it an arithmetic sequence. Over here, a geometric sequence, it doesn't have a common difference. Right here it has a common ratio. What is a ratio? It's a fraction, guys. Okay? So an arithmetic sequence has a common difference. A geometric sequence has a common ratio. Now, you're thinking, what the heck's a common ratio? Well, it says right here, you find this common ratio, R, by picking a number and dividing it by the previous number. So on the other one, we were subtracting. You picked the number 1 and you subtracted the previous number from it. On this one, you pick a number and you divide it by the previous number. Okay? So it says right here, R, you could do a sub 2, which is this one, divided by a sub 1, which is this one, and that'll be the common ratio. Or you could just simply, oh man, I did this backwards. Ladies and gentlemen, please, this is very, very wrong. Please go to this on your notes and make that an a sub 2 and change that to an a sub 1. Because you're supposed to take a number and divide it by the previous one. It's supposed to be a sub 2 divided by a sub 1. So it should be a sub 2 divided by a sub 1. I am sorry. Major typo. Please don't let that slide. Please change it. Okay? So remember, A sub 1 is up here, A sub 2 is right there, A sub 3, A sub 4. The A sub, the number is just the order that it's in. So the common ratio, you simply take A sub 2, put it over A sub 1, that's 243 divided by 2, or 729. And if you reduce it with the calculator, you can reduce by 243 actually, and you will get 1 over 3. And the calculator could do that reducing for you. Anyhow, the common ratio is 1/3. Now, you didn't have to use the first and second term. You didn't have to do the second one divided by the first. You could have done A sub 4 divided by 81, A sub 3. So you could have done it 27 divided by 81, but that also reduces to 1/3. So either way, your ratio is 1/3 on this list, your common ratio, that is. And once again, this list, 729, 243, 81, 27, what's happening with this list? It's getting smaller and smaller and smaller, right? Now, the question is, could I find the machine that produces this list? And the answer is yes. All I need to know is this new A sub nth rule. Okay, to find the machine that produces this list, we need to have this A sub nth rule memorized. Okay, so on arithmetic, we had this A sub nth rule right here. A sub n equals A sub 1 plus parentheses n minus 1 times the common difference d. The other one's very similar to it. It starts again with A sub 1. But instead of plus, you have multiplication. And the n minus 1, technically it's still going to be together, but there is no common difference. There's a common ratio. Let's go to the one that we're learning right now. Here it is. Starts out the same. A sub n equals A sub 1. That's your first term. But it's a multiplication, and then it's the common ratio, not common difference. And notice the n minus 1 that used to be in parentheses is now an exponent. Are you with me? So let's take a look at the list that we were dealing with. It's up here, 729, 243, 81, 27, getting smaller and smaller and smaller. Does anybody know this next one? 9. The next number, you think it's 9? Could be.
9, yeah.
In order for us to verify that, we should figure out this machine. So what we're going to do is we're going to plug in our A sub 1 value, which happens to be the first number up here, 729. I wrote that down, A sub 1, 729. So I'm going to take the 729, place it right here, which ends up being the number out here in the front. The common ratio, we said, was 1/3 if you reduce it correctly. So you get 1/3 right there in the common ratio. And the n minus 1 is simply n minus 1. So this is the machine that produces that above list. If you don't believe me, check it out. What if I were to plug in a 1 right here? Will it give me the first number on the list? Let's see. What's 1 take away 1?
0.
And what's 1/3 to the 0 power? And what's 1 times 729? Hey, it is the first number on the list. If you were to plug in 2 right there, it'll give you the second number. Plug in 3, it'll give you the third number. It will give you that. That's the machine that produces the list. And that's what I explained down here. This function produces this list, and it'll give you any number on the list. Example, I could find the 8th number on the list, noted as A sub 8, by simply plugging in 8. If you want to find the 10th number, plug in 10 right there and work it out. If you want the 20th number, plug in 20 and work it out. You want to find the 5th number, plug in 5 and work it out. So if I want to find the 8th number, I'm going to plug in an 8 right there. So this n is no longer n, it's now an 8. You see that? So what's 8 take away 1? It's 7. And 1/3 to the 7th power, that's too much for me to do in my head. If it were 1/3 squared, yeah, I would rewrite it as 1/9, or even 1/3 to the 3rd, I would write it as 1/27. But 1/3 to the 7th, I'm going to use my calculator. I already know that 1 times 1 times 1 7 times is still 1. But 3 to the 7th, I'm going to do that with my calculator, and I will get 2,187. So ladies and gentlemen, we now have the A sub 1 term, the first term on my list, times the fraction 1 over 2,187. And if you do that on the calculator, you will get 729 over 2,187. And if you reduce that on the calculator, you will get 1/3. So this happens, this is a weird situation, that our answer, our 8th term on the list happens to be 1/3, which is the same thing as a common ratio. That's just coincidence. I didn't know that happened, right? That was coincidence, not on purpose. So you could find the 9th term if you wanted to by plugging in 9. You could find the 5th term by plugging in 5. I hope this makes sense to you guys because we will have to use this. So please memorize this right here. A sub 1 is the first number on your list. The common ratio. How do you find the common ratio? You simply take a number and divide it by the previous number. 27 divided by 81. That's what you do to find the common ratio. And if you have your first number and the common ratio, you have the machine that produces a list, and that means you could find any number you want. Now, on top of that, I saw in the midterm that they'll give you some lists, and they don't tell you if it's arithmetic or geometric. So you must be able to look at a list of numbers and determine if the list is arithmetic. That means it has a common difference. It might have a common difference. Or it might be geometric. That would mean that it has a common ratio. Or they're just giving you some random list and it's neither. It's not arithmetic or geometric. So you got to be able to look at a list and see if it's arithmetic, geometric, or neither. So how about this? Let me just randomly do this right here. How about if I go 8, 16, 32, 64, ... Is this arithmetic or geometric? You guys tell me, is it arithmetic or geometric? Now, when I say is it arithmetic or geometric, I'm really asking you, does it have a common difference or does it have a common ratio? So what do you say? So in order to determine if this is a common difference or a ratio, you need to calculate it. The common difference, you're going to pick any number and subtract it from the previous number. Subtract the previous number from it. So you're going to say 16, take away 8. The answer is 8. But the word common means that it happens all the time in this case. So if I were to subtract 32, take away 16, do I also get 8? The answer is no. So there is no common difference. Because if I go 32, take away 16, I'll get 16, not 8. So there is no common difference. So now you try for the ratio, the common ratio. What do? It's a division problem. So if you take any number and divide it by the previous number, if I say 16 over 8, well, that's 2. All right, but let's see if it's common. How about 64 divided by 32? 64 divided by 32, yeah, that's also 2. Or how about 32 divided by 16? 32 divided by 16, yeah, that's also 2. So there is a common ratio. And that makes total sense. Because if the common ratio is 2, that means that it's growing by 2. So 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. Now let's compare that with an arithmetic. An arithmetic would be something like this. 8, 10, 12, 14. Right? Why is that arithmetic? Because there's a common difference. All of these have patterns, right? This pattern had a common ratio of 2. This pattern has what? A common difference. A common difference of 2. Common difference of 2. The D equals 2 here. What does that mean? Up here, a common ratio means that you multiply by 2 to get to your next one. Multiply by 2 to get to your next one. Multiply by 2 to get to your next one. Down here, the common difference is you simply add 2 to get to your next one. Add 2 to get to your next one. Add 2 to get to your next one. Make sense? So, arithmetic, you're really adding positive or negative numbers to get from one number to the next. Or I should say, you're really adding the common difference to get from one number to the next. Geometric, you're multiplying. And if we go back to the let's go back to the actual formulas. This one's arithmetic, and I know on arithmetic I end up adding the common difference. That's why there's a plus here. You have your first number on your list, and you know you're going to be adding to get to your second number. Maybe adding a negative. But over here on this formula, you're at your first number on your list, and you're going to be multiplying by the common ratio to get to your next number on your list. So when comparing the two formulas, there's that important detail that on arithmetic, you're adding to get to your next number. maybe adding a positive or a negative common difference. And in geometric, you're multiplying to get to your next number by your common ratio. Now, sometimes I might give you a totally random list of numbers that's neither arithmetic nor geometric. So, for example, if I told you, is this arithmetic, geometric, or neither? This one right here, is it arithmetic, geometric, or neither? Neither. Geometric? So, if I divide 4 by 2, what would that be? If you're saying geometric, you're saying common ratio. What's 4 divided by 2? 2. What's 12 divided by 6? 2. Looks good so far, but what's 6 divided by 4? That's not 2, so it cannot be. Does it have okay, so it does not have a common ratio. I mean, it has a common ratio here and here, but not right here in the middle. So it cannot be geometric. Could it be arithmetic? Does it have a common difference? The difference is 2, right? 4 take away 2 is 2. 6 take away 4 is 2. But 12 take away 6 is not 2, that's 6. So it does not have a common ratio. It does not have a common difference. So right here you would say neither. It's just some random list of numbers. Now, whenever you do have an arithmetic or when you do have a geometric, you're supposed to be able to find any number on the list because you're able to use the formulas. And this video is long enough. I guess let's just take a look at our actual homework. So just a quick instructions on the homework. Ladies and gentlemen, what do the instructions say right here? Determine whether it's arithmetic, geometric, or neither, and explain. The explanation part, it's just, if it's neither, it doesn't have a common difference, doesn't have a common ratio. So you need to test and see whether it's a common difference or common ratio. So how are we gonna start number 1? What do you guys want to check? Do you think this has a common difference? Do you think it has a common ratio?
Oh, it's 5. Add 6. Wait.
Okay, so instead of guessing, let's actually take a number and subtract the one before it from it. So 13 take away 7, what is that? 13 take away 7, that's 6. How about 19 take away 13? 19 take away 13, that's also 6. How about 25 take away 19? 6. So we know that there is a common difference of 6, which means that it is arithmetic. So everybody write that down as your answer. Arithmetic, the explanation, because it has a common difference of 6. Now, if that 6 were not in every single one of these, in between every single one of these, then it wouldn't be working. It would not be arithmetic. It might be geometric or neither. How about number 4? What do you guys say about number 4 since we're here? Do you think there's a common difference? What is a...
Oh, it's like, it's 3 but multiplying.
Okay, 3 but multiplying. Okay, that's good. But how about this? If I try 9 take away 3, that's 6. 81 take away 9, it's not 6. So it's definitely not a common difference. But if we go for common ratio, let's see common ratio. If I go 9 divided by 3, what's 9 divided by 3? 3. How about 81 divided by 9? 81 divided by 9. Is that 3? No, that's 9. So it doesn't have a common difference. No. It doesn't have a common ratio. No. So right here it'd be neither. Does that make sense? So you're going to be picking a number, subtracting the one before it. And if that difference is in common in all of them, you call that arithmetic. If you take a number and divide it from the one before it, and it's consistent and there's a common ratio in all of them, then it's geometric. So if there is no common difference, there is no common ratio, that's where you say neither. Now, this next part of the homework is pretty straightforward as well. It says find the next 3 terms. So I would like you to, and it says in each geometric, they tell you it's geometric. They tell you it's geometric, which means that there is a common ratio. There is a common ratio. But they want you to find the next 3 terms. Okay, so a sub 1 is 2,500. A sub 2 is 500. A sub 3 is 100. They want the next three terms, right? Right?
Yes.
So the next three terms would be a sub 4, a sub 5, and a sub 6. I would like you to label it like this. So let's find the next three terms. Let's find the fourth term on this list. Well, we know it's geometric, so we need to find that common difference D. What is the common difference D? How do I find it? I pick a number and divide it by the previous number. So what is 100 divided by 500? I mean, you could have done it also with 500 divided by 2,500. What is this really? It is 1/5. It's not the same thing. So the common ratio is 1/5. Now, what does that mean? That means that from 2,500, if you multiply it by 1/5 on the calculator, it gives you 500. If you go 500 times 1/5, it'll give you 100. So how am I going to get the fourth term? Multiply it by 1/5. So on a calculator, if you go 100 times 1/5, you should get 20. Now, how am I going to get from 20 to the next one over here? By multiplying by 1/5. If you multiply 20 times 1/5, you'll get 4. And how am I going to get to my last term over here?
Same thing.
Same thing, multiply it by 1/5. And that becomes 4/5. How did I get that? Well, multiply by 1/5, put the 4 over 1, multiply 4 times 1, and 1 times 5, you end up with 4 over 5. So these are your answers right here. The next three terms, actually, scratch that one out. The next three terms are 20, 4, and 4/5. Are you with me? Okay. Some of them are fun with fractions. I'll probably explain that on a separate video. Now, down here is the fun part. It says, write an equation for the nth term. In other words, you want your a sub nth rule for a geometric sequence. And we already learned from our notes that the rule is a sub 1 times r to the n minus 1 power. So all you have to do is identify your a sub 1 term. What's the a sub 1 term, guys? 3. A sub 1 is the first number, 3. So you can have 3 times, and up here n minus 1, but we still need that common ratio r. How do I find a common ratio? I pick a number and divide it by the previous number. Ladies and gentlemen, what's the common ratio here? What's the common ratio here? Negative 8. Negative 24 divided by 3, that's negative 8. Again, the common ratio, in this case, I took the negative 24 and divided by the previous number, 3. So that gave me negative 8 as my common ratio. The ratio is negative 8. Now this right here, ladies and gentlemen, is the machine that will produce the list. So it says write an equation. So my equation is, I should probably write it correctly, a sub n equals, this is my equation, a sub n equals 3 times parentheses negative 8 to the power of n minus 1. And then it says find the ninth term. How do I find the ninth term? How do I find the ninth term?
I do not know.
By plugging in 9 into the machine.
Oh, yeah.
So all I need to do is plug in 9 into that machine, and of course you could use a calculator, 3 parentheses negative 8 to the power of 9 minus 1. And you don't have to do that on the calculator. On the calculator I would do this, 3 parentheses negative 8 to the power of 8. So do that on a calculator, please. What is 3 parentheses negative 8 to the power of 8? While we're waiting, I'll do it. 3 parentheses negative 8 to the power of 8.
It's 503316.
It's 50331648. So it's 50,331,648. And that would be the 8th term on this list. So I hope this kind of helps. I will make a video explaining the other ones.